Good evening, 5th graders. Welcome to Lesson 11-12, Part 2, Find Volumes of Composed Figures. The essential question for tonight is how can you find the volume of rectangular prisms that are combined? Tonight I'm going to teach you a different strategy than we learned last night. Yesterday we talked about how you can find partial volumes and add the two together. But tonight's strategy is going to be a little bit different. We're going to talk about how you can find an imaginary volume and subtract it from the rectangular prism. Let me show you an example. Let's take a look at this example right here. The subtraction method. You can subtract the volumes of prisms formed in empty spaces from the greatest possible volume to find the volume of a composite figure. Here's a step 1. You have to find the greatest possible volume. In other words, you have to look at this as if you had the entire rectangular prism filled in completely. So we would have length times width times height of this rectangular prism. So imagine this is one gigantic rectangular prism completely filled in its entirety. So we would have length times width times height. So that would be 10 times 4 times 6. Our length is 10 inches, our width is 4 inches, and our height is 6 inches. Well, we know 10 times 4 is 40, and we would do 40 times 6. And this would give me a volume of 240 cubic inches. All right, so I'm going to write 240 right there. Now, step 2 is going to be where we're going to subtract the invisible portion right here. Here's the reason why. We found the volume of this entire rectangular prism, but as you can see, this portion right here is not really there because this is a complex figure. We have two rectangular prisms combined, but we're going to use a strategy of just find the whole volume of length times width times height, and then we're going to subtract this smaller portion. So now our job is to find the volume of this smaller portion. Now let's see what we know. We know that the length will be 8 inches, and the reason why the length has to be 8 inches is because it was originally 10 inches down here and 2 inches up here. And you know that 2 plus 8 would be 10. So we have 8 to be our length for this invisible portion of the rectangular prism. So I'm going to go ahead and write length times width times height here, and I'm going to go ahead and write 8 to be the length. Now let's find the width. Now the width on this one is actually going to be congruent with our other rectangular prism. Do you see how we have a 4-inch width here? Well, it's going to be congruent as well right there. So I would say my width is still going to be 4 inches wide. And now let's find the height. Now you can see we've already written in 4 inches, but I'm going to show you why. Up here, do you see how we originally had 6 inches? I'm going to put a 6 right there to show you why. Now remember, if you look right here, if this is 6 inches right here, just like this top one shows us, we know 6 is right there, but if you look over here, this would also have to equal 6. And we already know 2's already been used at the bottom portion, so we have to say 2 plus what would equal 6. And I know this invisible portion would have to be 4 inches, and that's why we plugged in 4 right there for the height of our invisible rectangular prism. So that's why it has a height of 4. So now we have 32 times 4. Now I know 32 times 4 would have to be 128 cubic inches. So that would be the volume of my second rectangular prism, because remember we had a length of 8, a width of 4, and a height of 4. So our volume was 8 times 4 times 4, which would give us 128 cubic inches. Now, the last step is we're going to subtract this invisible portion volume, which is like our rectangular prism B, from our original full greatest possible volume, which was 240. So we have 240 minus 128. And I'm just going to regroup right here, and I have 112. So our final grand total for this complex figure right here would be 112 cubic inches. Let's go ahead and try that strategy for number 2 in your Go Math book. Remember, our goal is to find the volume as if we had an entire filled-in rectangular prism. So I'm going to go ahead, and if you want to just kind of create what I just did there, you can do that as well. I'm going to go ahead and find the volume as if it was one entire rectangular prism. All right, here we go. We're going to start off with length times width times height. Now, as you can see, I know that my length is going to be 14 centimeters. So if this is 14, we know this has to be 14. So let's go ahead and fill in this unknown portion right here. 6 plus what is 14? If you said 8, you are correct. So I'm going to put a little 8 right there just to help me for a future subtraction part. So we have our length times width times height. Now we've just discovered the length of the full rectangular prism would be 14 centimeters. So let's go ahead and plug in 14. Now let's find our width. Now, this might be a little bit more difficult because you see two portions. I've got 12 centimeters here, but then we have to come over to this portion right here. Do you see how they've given me a little helper? 4 plus 12. If we combine these two together, it would actually equal this full width. So that is 12 plus 4 to be 16. Will you write a 16 right next to that? And we're going to put 16 down as our width. And of course our height is given to us right here to be 2. So I'm going to go ahead and put in a 2 for my height. So now to find the volume of this full rectangular prism, we'd have 14 times 16 times 2. So let's go ahead and work out 14 times 16. And when we do that, we have to show our work. I have 84 for my first partial product. I'm going to put down my spacer and erase away my 2 that I regrouped. And you should have 140 for your second partial product. And when you add those two together, you should have 224. Now remember, that's just going to be our base. So I'm going to write 224 right there for my 14 times 16. And now we have to multiply that by 2, my height, to be able to get the volume of this full rectangular prism. So we have 224 times 2, and that would be 448 cubic centimeters. Now that would be my volume of my original full rectangular prism had we not had this invisible portion right here. So let's go ahead and write that down as 448 cubic centimeters. Now, we're not finished though because that's not the true volume. Now our next step is to subtract this invisible portion from 448. All right, boys and girls, so what we're going to do now is we're going to take our formula, length times width times height, and let's see what we know. What we know right now is my length will be 8 centimeters because remember, 6 plus 8 we found to be 14. So this invisible portion right here should be 8 centimeters. So I'll put in 8 for my length. Now my width, boys and girls, for this portion right here is going to be congruent with the width on the other side of the rectangular prism, 4 centimeters. Because remember with rectangles you have 2 sets of congruent sides. And my height will remain the same. Do you see how we have 2 centimeters here? It'll be the same right there. So I'm going to write a little 2 right there to remind us that the height will be 2. All right, we know 8 times 4 is 32. And we'll multiply that by my height to get the full volume of our invisible rectangular prism. 32 times 2 is 64. So my last step is going to be subtracting my invisible rectangular prism volume from my original full rectangular prism. So we would do 448, and we're going to subtract 64 from that. All right. 8 minus 4 ones is 4 ones. I can't do 4 tens minus 6 tens, so let's regroup. Borrow 10 tens, and we have 14 minus 6 would be 8 tens, and we have 3 100s. So our final volume would be 384 cubic centimeters would be our volume. Okay, I'm going to walk you through the formula that this would actually be if we actually were to solve it, if we were to do the subtraction method. Remember, we would have length times width times height of the original full rectangular prism had we created a full rectangular prism, which we will do together. And we're going to subtract it by the length times width times height of our imaginary rectangular prism that we will fill in this extra portion with right here. So let's go ahead and find the length times width times height of our full rectangular prism if we were to build it. I could see this full length is 8 inches. The width, as you can see, is 3 inches. Do you see right here we have 3 inches wide? And my height for this full rectangular prism would be 6 inches high. So we have 8 times 3 times 6. Now we have to subtract our imaginary rectangular prism. Now let's go ahead and find our length. The length for our imaginary one, remember, it's only going to go this far. It stops right inside here. Okay, so we would originally have 8, but we're going to shave off 1 inch. Now the reason why we're shaving off 1 inch is because this portion right here is 1 inch wide. So it would be 8 minus 1 would give me this portion right here. So I'm going to go ahead and write 7 inches for this inside portion. And let's find our width. The width right here is 3 inches wide. Okay, so if I look right here, my width would remain the same. 3 inches here. It's going to be 3 inches here as well. So my width is going to be 3 inches still. But my height, let's find the height. Now the height was originally 6 inches, but we're going to take off this 1 inch portion right here because now it's only this tall. All right, so we have 6 minus 1 would give me this portion, which would be 5 inches. So my formula would be 8 times 3 times 6 minus 7 times 3 times 5. So let's go ahead and solve my original rectangle. 8 times 3 times 6. Well, I know 8 times 3 is 24, and 24 times 6 is 144, and that would be cubic inches. Now we want to subtract 7 times 3 times 5. Well, I know 7 times 3 is 21, so I have 21 times 5 to find the volume of my imaginary rectangle, my imaginary rectangular prism. So that would be 105. We will subtract cubic inches. All right, so now we have 144 minus 105. All right, let's go ahead and do this. When you subtract, you should have 39 cubic inches to be the volume of our complex shape. Now looking at number 6, what is the volume of the composite figure below? I would suggest that the method that we learned yesterday, which is adding the two combined volumes of two rectangular prisms that are complex, looks like it might be an easier solution to solve for number 6. So let's go ahead and revisit this one because this is what we learned yesterday and I don't want you to forget it. And it is a strategy. Now, of course, if you feel comfortable with the method that I just taught you tonight and you want to go ahead and subtract the invisible rectangular prisms that you can visualize right here, and of course that would be congruent, so you'd have 2 of them, that's another method that you can do and you can try on your own. But let's go ahead and make 2 rectangular prisms, A and B. And let's go ahead for number 6 and add the 2 partial rectangular prisms together to find the whole complex shape's volume. All right, let's start off with A. I can see that I have a length of 9 feet right here as well as here. So the volume A would have a length of 9. Let's find our width. Our width would be this long, and if it's this long here, if you look, then I can see that it is also congruent with this length right here, or the width. So if this is 12 feet, this would be 12 feet, and so would this be 12 feet. So I'm going to go ahead and make 12 feet to be my width. So here I go. I have 12 feet for my width. And now let's find the height. Now right here it's telling me that this would be 6 feet high. Okay? Right here you can see it says 6 feet. It belongs with this portion right here. So we have 6 feet high for my height. So now we can solve for this first rectangular prism of 9 times 12 times 6 to get our rectangular prism's volume. So let's go ahead and do 9 times 12 to find our base, which would be 9 times 12, length times width. All right, 9 times 12, I'm going to go ahead and work it out right here. All right, 9 times 2 ones, it would be 18 ones, and I would have 10 tenths. Now I have to multiply my base times my height, which is 6. So we have 108 times 6. So let's remember, 6 times 8 is 48. 6 times 0 tenths is 0, plus 4 more is 4. And 6 times 1 group of 100 is 6. So I have 648 for my rectangular prism A volume. I'm going to write that right over here. And now my job is to find my volume of my rectangular prism B. Now let's see the dimensions that we know. Length is 27. The width looks like 12. And my height is already done for me, which is 6. So it'll be 27 times 12 times 6 to find that rectangular prism's volume. All right, 27 times 12. Let's go ahead and work that out. And you can do that along with me, or you can pause the video to try it on your own. But as I work it out, I have 54 for my first partial product. Let's put down our spacer. And you should have 270 for your second partial product. And when you add that up, you have 324. Now that's just for the base, 324. Don't forget, we still have to multiply it by 6 for my height. So 324 times 6 for the height would give me 24 ones, 14 tenths, and 19 hundredths. So it's 1,944. Now remember, because we chose to do the method of adding our two partial volumes, 1,944 and 648, we can just add them together. And when you add them up, you should have 2,592. And this is going to be found in cubic feet. All right, so your homework question tonight is going to be number 1. Which expression represents the volume of the composite figure? Pick A, B, C, or D. Now, because this is the only question we're asking you to do for homework, I also want you to write the volume as well so I can see if you understand how you got your answer. So go ahead, pick the correct expression that you would use to solve this complex figure's volume, but I also want you to find the volume using the expression that you picked. Please rate yourself at the top of the page, level 1, 2, 3, or 4. And we will check this tomorrow in class, as well as doing some other practice problems using the subtraction method as well as the addition method, just to make sure you can understand how to find the volume of complex figures. Have a great night. Bye-bye.